Good morning, dear children. In our previous classes, we were discussing on the nature of force, different types of force, contact and non-contact forces. Today, we are going to learn another topic, pressure. This is the last topic of this chapter also. Pressure exerted by solids, liquid pressure and atmospheric pressure. So let us start.
When you hammer an iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, then applies a force on the wall and tries to pierce it. Now let me ask you a question. What will happen if you hammer the pointed side and try to pierce the flat side of the nail? You will find it difficult to push the flat face of the nail through the wall even if you apply more force than the first case. Then what is the reason for this? This is because of the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface. But the question is why? First, notice that the area of the tip of the nail is very less as compared to the area of the flat surface. This tells us that the area of the surface on which the force is applied matters. We will discuss this in detail, but first let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it is acting. That is, pressure is equal to force by area. The SI unit of force is Newton. You know that, which is denoted by the letter capital N, and that of the area is equal to m square. So the SI unit of pressure is equal to Newton per meter square, which is also called Pascal, which is denoted by PA. Here you can see that the area is in the denominator of the fraction. Then what is this area? Area is nothing but the area on which the force is applied. If we keep the force constant and increasing the area, then what will happen to the pressure? Will the pressure increase or decrease? Use pure mathematical logic to answer this. If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Surely it will decrease. So the pressure will decrease if I increase the area by keeping the force constant. With this knowledge, let us go back to the example we saw earlier, the nail on the wall. Here we are applying the force perpendicular to the surface of the wall. If you notice the tip of the nail, it has very small area. Here the first picture. Compared to the flat surface of the nail, that is the second picture. And hence the area of contact with the wall reduces to great extent in the first case. Hence, the pressure applied by the tip on the wall is greater than the pressure applied by the flat surface. That is why it is easy for the tip of the nail to penetrate through the wall. You can even use the drill machine to drill the hole into the wall. You see that it has the pointed tip for the same reason. You can easily cut vegetables using the cutting edge of the knife. But if you use the blunt edge of the knife, it will be difficult to penetrate it. What is the reason in this case? Well, in the first side, the two edges might look same to us. But if you look at them carefully, the cutting edge has small triangle-like shapes with sharp outer points. The other edge has nothing of this. So if you cut the vegetables with the cutting edge, the area of contact between the vegetables and the knife is greatly reduced. Hence, more pressure is applied on the vegetables using the cutting edge of the knife. Pressure exerted by liquid. Let us take a plastic bottle and make holes all around near the bottom but at the same height, which means make all the holes at the same level. Now fill the bottle with water. Look, water is coming out of all the holes, not just one. Water is coming out because of the water pressure, which means water is exerting pressure on the walls of the container. You can notice that water coming out of all the holes fall at the same distance from the bottle. What does it mean? This means water pressure is equal in all the direction at a certain depth. Now let us take another bottle of exactly same size and shape. Then drill holes at different height and fill the bottle with water. Look, again the water is coming out of all the holes. What else do you observe? As you can see, water falling from the hole which is near the top is at the shortest distance from the bottle, and the water coming out of the hole near the base is falling at a greater distance from the bottle. So what do you understand from this? Water comes out of the bottle because of water pressure. Water coming out of the hole nearest to the base goes farthest. So this means water pressure increases with depth. That is, water pressure increases with the increase in the height of the water column which is exerting the force. From these two experiments, we can say that water exerts equal pressure in all direction in same depth, and water pressure increases as we go deeper. Let us do another activity. Take a glass tube which is open at both the ends. Then close one of its ends with a balloon. Fill water in the tube from the other end. Then what happens? You will see the size of the balloon increases. Pour more water and keep observing the size of the balloon. You will see that as water is added to the tube, the balloon starts to bulge. This bulge of the balloon goes on increasing as we pour more amount of water. This activity shows that liquid exerts pressure in downward direction also, and the pressure exerted by a liquid at the bottom depends on the height of the water column. Atmospheric pressure. You know that there is air all around us. This envelope of air is known as the atmosphere. This atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. We know that pressure is equal to force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in the cylinder is the atmospheric pressure. But how large or small is the atmospheric pressure? Let us see. When you press the sucker, most of the air between its cup and the surface escapes. The sucker sticks to the surface because the pressure of the atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. This activity gives you an idea about the magnitude of the atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. So that's all about pressure. Thus we have come to the end of this chapter, force and pressure.